Bismillahirrahmanirrahim. Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Aisyah binti Hamidi. Today, our group will present about radical reaction. First, what is radical reaction? Radical is an atom, molecule, or ion that has unpaired valence electrons. And then, what is radical reaction? Radical reaction is when the radical react to complete the electron octet of valence shell. A radical can break a bond in another molecule and extract a partner with an electron, getting substitution in the original molecule. Radical also can add an alkenes to give a new radical which can causing an addition reaction. Carbon radicals are formed by homolytic cleavage of covalent bond using either heat, light, or radical initiator like peroxide. Next is stability of radical. Free radicals do not have an electron octet due to the unpaired electron. Radical stability increase in the order. Methyl is lower than primary, primary is lower than secondary, and secondary is lower than tertiary. Tertiary radical is the most stable, and the methyl radical is the less stable than others. Next is a common reaction of radical. Free radical reaction has a high reactivity. Because of it, free radicals have the high potential to be extremely powerful chemical tools and extremely harmful contaminants. They have a three common phases of radical reaction chain, which are initiation, propagation, and termination. I will explain one by one. First is initiation. In initiation phase, the greatest of radical species is the initially step. This is a homolytic curve event in most cases, and it also takes place very rarely due to the high energy barrier involved. In normally, the influence of heat, UV radiation, or a metal containing catalyst is necessary to overcome the energy barrier. As you can see, the molecule of chlorine and bromine will both undergo homolytic cleavage to form a radical when dominated to heat or light. Other functional groups which also tend to form radical when exposed to heat or light are chlorofluorocarbon, peroxide, and halogenate amine like NBS. Okay, second is propagation. In propagation, first discuss about the chain part of the chain reaction. Once the reactive free radical is generated, it can react with stable molecule to form the new free radical. The new radical will go on to generate yet more free radical, and so on. The propagation steps are often involve hydrogen abstraction or the addition of the radical to the double bond. Last is the chain termination. It occurs when two free radical species react with each other to form a stable or and non-radical atom. This is a very thermodynamically downhill event. It is also very rare due to the low concentration of radical species and the small likelihood of two radicals colliding with one another. In other words, the Gibbs free energy barrier is very high for this reaction and mostly due to entropic rather than entropic concentration. The active side of enzyme, of course, it can evolve to overcome this entropic barrier by positioning two radical intermediate adjacent to one another. Okay, this is the example of termination, where the two free radical species will react with each other to form a stable one.
Assalamualaikum, my name is Wana Anis and I will explain about the halogens of alkane. So, in halogen of alkanes, there is three steps in the halogen mechanism. So, there is initiation, propagation, and termination. So, I will explain to you all about the three of the mechanism or steps in the halogen of alkanes. For example, chlorine molecule with the presence of UV light it will produce okay. So in the initiation step, the molecule of the chlorine with the presence of UV light as the energy will break down the bond between chlorine molecule and produce two free radicals of chlorine. This is called the initiation. Okay, the bond will broken if there energy present such as UV lights, heat. If there is no energy, so the bond between the chlorine will not break. Next is the propagation step. The first step is when chlorine free radicals from the initiation step will approach methane molecules. This is methane molecules. Chlorine will combine with hydrogen and form hydrogen chloride and one methyl free radicals. So the methyl will become free radicals and the free radical of chlorine will combine with hydrogen and form hydrogen chloride. This is the first step of the propagation. The second step of the propagation is when methyl free radicals from the previous step methyl free radicals will react with chlorine molecule they will react and form chloromethane plus one chlorine radical. So this is the second step. This is methyl free radicals from the step 1 of the propagation, and it will react with a molecule of the chlorine, and then it will form chloromethane. This is chloromethane. Chloromethane, and this is chlorine free radicals. This is free radicals. So this is the second step of the propagation. The last one is termination step. Termination step is when there is a reaction that will occur and product will be formed, but there is no free radicals will produce, and that is the last reaction that will occur. For example, we take 2 chlorine and with 2 chlorine or free radicals. It will react with each other and it will form fluorine molecule. Okay, so as you can see, there is no free radicals are formed. There are no free radicals are produced by the molecule of the fluorine because this is a free radical and this is free radical. When they are react with each other, they will form molecules and not free radicals. So this is the termination step. There is no more free radicals, and this is the last reaction that we occur. Thank you.
So, Assalamualaikum and hi, my name is Nurul Islam Fakri, and for this topic, I will briefly explain about the free radical addition reaction. So, first and foremost, do you know what is the free radical addition reaction? So, free radical addition reaction is the addition reaction in which the attacking reagent is the free radical. So, for example, peroxide effect anti-Markovnikov rules is a Markovnikov rules is a quite general but not universal. So the addition of HBr is unsymmetrical alkenes in the presence of organic peroxides ROOR takes a cos opposite to that suggested by Markovnikov's rule. So thus anti-Markovnikov rule states that when an asymmetric reagent adds to an asymmetric alkene, then the positive parts of the reagent attached to the double bond carbon atom which bears lesser number of hydrogen atoms. So this phenomenon of anti-Markovnikov addition of HBr caused by the presence of peroxide is known as a peroxide effect. So an unsymmetrical alkene is one like propane, where the groups at either of the carbon-carbon double bond are different. So the reaction happens under the same condition as with a symmetrical alkene, but there is a complication because the hydrogen and the bromine can add into different way. So which way they add depends on whether they are organic peroxides or oxygen present or not. So let's see to this. So this one HBr with peroxides, and for this one is HBr with no peroxides. So okay. So normally when a molecule H adds to a carbon-carbon double bond, the hydrogen becomes attached to the carbon with the more hydrogens are on already. So this is known as Markovnikov rules. So because the HBr acts on the wrong way around in the presence of organic peroxides, this is often known as the peroxide effect or anti-Markovnikov addition. So in the absence of peroxides, hydrogen bromide adds to propene via an electrophilic addition mechanism. So that gives the product predicted by Markovnikov rule. So let's see to the free radical mechanism. So for the first one is chain initiation. So this is exactly the same as the ethane case above. And for the chain propagation, okay, here when the bromine radical joins to the propene, it attached so that a secondary radical is formed. So this is more stable and so easier to form than the primary radical, which would be formed if it attached to the other carbon atom. So that radical reacts with another HBr molecule to produce one bromopropane and another bromine radical to continue the process. And the last one is chain termination. So eventually two free radicals hit each other and produce a molecule of some sort. So the process stops here because no new free radicals are formed. Thank you.
Assalamualaikum and hi friends. Now I will be explaining about polymerization. First and foremost, what does it mean? Let me tell you. Polymerization is the process of converting small molecules called monomers by combining chemically to produce a very large chain-like or network molecule called polymers. In straightforward polymerization, alkenes form polymers through simple radical reactions. They form useful compounds such as polyethylene and polyvinyl chloride that is also known as PVC. Basically, there are two types of polymers. Firstly, homopolymers consist of single species of the repeating units from the same type of monomer. Copolymers consist of two or more types of the repeating units that have two or more types of monomers. Next, I will be showing you the polymerization reactions, which are also divided into two types. First is addition polymerization, and second is condensation polymerization. As for addition polymerization, the name suggests addition polymers form when an addition reaction occurs. It is also known as a chain growth reaction. The repeating monomers form a linear or branch structure depending on the type of monomer. During addition polymerization, the monomers rearrange themselves to form a new structure, but there is no loss of an atom or a molecule. Figure 1 shows an example of polymerization of ethene into polyethene. The double bond between two carbons in ethene enables the molecule to form a longer chain. Next is condensation polymerization, a process in which two monomers react to form a larger molecule and eliminate a smaller molecule, usually water, ammonia, methanol, and hydrogen chloride. Figure shows the example of polymerization of carboxylic acid, an amine, forming amide, and water molecule through condensation reaction. In this reaction, the byproduct is water. Notice that an acid group remains on the other end of the chain, which can react with another acid monomer to continue form a long chain.